Good afternoon, everyone. If you're here to learn a little bit about the AWS approach to securing generative AI, congratulations, you are in the correct location. And thank you very much for spending your afternoon with us. I know we're all excited to get out to the desert and enjoy some time at Replay this afternoon. So my name is Jason Garman. I'm a Principal Security Specialist Solutions Architect here at AWS. I've been here for about 2.5 years, and I'm excited to share with you some information about how we feel about generative AI and generative AI security, and how we can help you secure generative AI applications. So we have 3 things on our agenda today. We're going to start with an understanding of the AWS approach to responsible AI and to secure AI. We're going to talk about the frameworks that we use, how we kind of categorize security in generative AI, and then we'll move into the tech stack that underlies all of the AWS generative AI services and look at each one of the layers of that stack to understand how we help you secure your generative AI applications on AWS. And then finally, we'll cover a couple of AWS security services that you'll want to take a look at and how to integrate those with some best practices into your own generative AI applications. So we'll get started, and I'm not going to tell you a lot about how generative AI powers new innovation. We've heard a lot about that from a ton of different people, probably a lot of folks at this very conference. But what we are here to talk about is how we can address some of the new risks and challenges that come with the adoption of this new and emerging technology. There's a lot of information out there, and what I'd like to do is start with the 8 different dimensions that we at AWS use to define responsible AI. Now, this is a lot. I'll be honest, I share this with customers a lot. I talk to customers all the time about how to secure their generative AI workflows. And they start and they come to me and they say, this is overwhelming. This covers everything from societal level risks about biases, making sure that you are fair to all groups of people, for example, in your responses for your AI applications, all the way down to how do I give my assurances that I can keep my customers' data secure and private, even when using these new AI services. So there's a lot to really understand here, right? And so when I talk to customers, what I like to do is take these 8 dimensions of responsible AI and break them down into 2 different broad categories. And I call these decomposing responsible AI. And I took a look at this and there's 2 different categories that I like to talk about. We'll start with safety. So safety of an AI system, the way that I typically talk about it with customers, is how do we design these systems to prevent harmful system output, encourage accurate and relevant responses, and align with those goals for fairness, bias. You all have a brand voice, I'm sure, for your individual companies, right? You want to make sure that your AI systems reflect that, for example. And when we think about safety and everything that falls under those categories, those are risks that really can be managed through applications of services, and we'll talk about these services later in this talk, things like bedrock guardrails. They can only be managed. So when you think about these risks, what you want to do is understand that you need to calibrate your risk levels appropriately, and then address these risks through the current systems. They're usually probabilistic systems at this point. So you have to think in terms of levels of acceptable risk for AI safety. On the security front, on the other hand, this is a broad set of constraints where we think about how do we design the system so that it's going to prevent from revealing sensitive or confidential information to unauthorized users. And the good news about security is we all have a lot of experience already with building secure systems. It's really a matter of understanding how to integrate those security systems inside of your generative AI application workflows. So that's why I say on that second bullet that the best practice here is to use traditional security controls to filter that data before it enters the foundation model. And you use deterministic, auditable, and explainable controls. And again, we'll look at this in the future slides. And today, we're really going to be focusing on that second topic, security. And how can we help you build secure systems that use generative AI services on AWS? And more importantly, what features in AWS enable you to get those secure outcomes? Another useful mental model that we use at AWS to help customers wrap their heads around this problem is what we call the generative AI security scoping matrix. Just a quick raise of hands. How many of you might have seen this already? We've had a couple of blog posts about it. It's fairly new. All right. Well, let's take a look at it. And I'm not going to spend a ton of time on this. We will have a link to this blog at the end of the talk, so you can definitely take a look at that and see all the details behind this. But what we do with the scoping matrix is when we talk to customers about their requirements for security and a generative AI implementation, our first question to them is, what is your use case? And how are you going to interface with that generative AI application or service? So we classify those into these 5 different scopes. If you're using an off-the-shelf generative AI application that's open to the public, things like Amazon Party Rock or ChatGPT, those are scope 1. Those have certain constraints in terms of privacy and governance, et cetera. And those constraints are different than when you go and move to the right with the different scopes. So if we look at scope 2, for example, that's an enterprise application. We'll look at Amazon Q later in this presentation, how you can build secure pipelines with Amazon Q Business. And then as you move into scope 3, we're looking at a builder's mindset more than a buyer's mindset. And you're using services such as Bedrock and understanding how to adopt that securely as well. And across all of these 5 scopes, you have these dimensions: governance and compliance, legal and privacy, risk management, controls and resilience. These are going to be driving the questions you're going to want to ask and how you're going to drive that secure development process if you're looking at those scope 3, 4, or 5 in this matrix. To look at this in a little more detail, this is just kind of an outline of each one of those security dimensions in the scoping matrix. And again, today we're going to talk about these in depth and how we at AWS help you address these goals when you adopt generative AI services on AWS. Now, like everything else here, we build these capabilities up and down the entire stack, the entire technology stack. And at the very bottom is the infrastructure layer, the foundation upon all of which this is built. And to talk a little bit more about that, I'm going to invite my friend up here, JD Bean, and he's going to tell you all about AWS infrastructure layer. Thank you.
Thanks so much, Jason. Hi, all. My name is JD Bean. I am a principal security architect in the AWS Compute Services Organization. I spend a lot of my time around some of our foundational compute services, including the Nitro system, as well as some of our confidential computing technologies, which include the Nitro system, as well as technologies like Nitro TPM and Nitro enclaves. So Jason said something really interesting earlier that I think is undeniably true, right? That generative AI brings with it new challenges and new risks for us as IT professionals and particularly security professionals. But I also think it's worth taking a step back and remembering and noting, of course, that a lot of the tools and the techniques and the approaches and the skills that have always been relevant to securing compute systems, or securing really digital systems, are still very much applicable in the generative AI space. So I'm going to start out speaking a little bit about this foundational layer, right? The aspects of things like GPUs and compute, as well as networking, et cetera, how these technologies can be used to provide a base level of security, and how customers can build on top of them to build their own generative AI systems, whether that's for training, inference, or other applications. So at a high level, right, when we think about what it means to have truly secure generative AI infrastructure that we can provide to our customers to build their own workloads on top, to provide that foundation, we think of it really through a lens of three attributes, right? Complete isolation of AI data from the infrastructure operator, right? The underlying physical hardware operator. The ability for customers to introduce isolation between themselves, their own operators, and the sensitive AI data that their systems process. And last is the critical importance of protecting infrastructure communication so that when sensitive data is moving back and forth between infrastructure components, that it always does so in a protected manner. Key to the way that we address some of these technologies at the infrastructure level is this concept of confidential computing. This is a term you may or may not have heard in the industry, and sometimes it can mean different things to different people. When we've had conversations with customers, we've kind of identified a very clear separation, right? That there's really two dimensions of confidential computing that customers are talking about us with. And the first one is really about the isolation of a cloud operator from, or just infrastructure operator from, for example, the contents of a customer's EC2 instance, right? This is that first dimension as represented by the green line, kind of demonstrating like the separation between these two security domains. The second dimension is actually separation and isolation between components that run within a customer's EC2 instance. Now, this can be important for a variety of reasons, which we'll talk about in a bit. But the second dimension, right, is really about isolation between, for example, customer data and code, or even interactive operators like administrators, and a particularly sensitive set of code and data that needs to be processed in an isolated fashion. When it comes to how AWS addresses these technologies, or these dimensions, right, there's kind of two primary technologies. The AWS Nitro system, which is the underlying technology that AWS uses to provide our EC2 virtual compute service. And the other is the AWS Nitro enclaves. The Nitro system is the primary technology at AWS that addresses dimension one, protection from the underlying infrastructure operator. AWS Nitro Enclaves is a powerful tool that can be used to address dimension two by providing that additional isolation within customers' environments. So, if you have not heard of the Nitro system before, I'm going to speak a little bit about it today to help folks understand a bit about what it is and where it came from. So on the left, you will see what came before the Nitro system. This is basically a very high-level representation of a fully software virtualized EC2 instance. And the last time we released something like this for our customers to use was about 2012. So this uses the Zen hypervisor, and it provides the customer instances, the small pink squares, right? Those are each customer's EC2 instance. And it runs on top and provides services to them, such as emulating things like networking interfaces or block storage devices. It does that through a privileged copy of an operating system called DOM0. AWS, over a period of about 10 years, set out to fundamentally change and reinvent and reimagine what virtualization can look like. And the end of the journey is pictured on the right side of this screen. This is the Nitro system. What we've done is removed the vast majority of the AWS software and features that needed to run on the same hardware as a customer's EC2 instances and moved them off onto special purpose hardware devices that we designed for the purpose of providing things like our VPC service, EBS storage, locally attached instance storage, and all of the other management, security, monitoring, orchestration that kind of makes up the EC2 service. What was left on our system mainboards were customer instances and a tiny, tiny purpose-built firmware-like hypervisor called the Nitro hypervisor. How did we do all this? Well, ultimately, there's about 3 real components to the Nitro system. There are those Nitro cards, and these really are the stars of the show. These are dedicated silicon, dedicated memory, discrete computing devices that ultimately allow us to provide hardware acceleration to the vast majority of what our virtualization system is. All the NVMe storage, all the block storage, the networking, the monitors, all of that runs on these Nitro cards. The Nitro security chip is a small component that sits inside or on our system mainboards. And the Nitro cards, which follow a process of secure boot and attestation, bring themselves up, and through the Nitro security chip, actually extend off their hardware root of trust into our system mainboards. So we have an incredibly strong hardware root of trust that allows us to know exactly what's running on every single server anywhere in the world in any of our facilities. It gives us a very strong root of trust that we can build the infrastructure up from. And last is the Nitro hypervisor. Extremely lightweight hypervisor. It basically carves up memory, CPU resources, gives them to virtual machines, and steps back out of the way, allowing our customers to have a bare metal-like performance on a virtualized system. So why am I telling you any of this? Fundamentally, the Nitro system is really a foundation for AWS. If you've listened to a number of our keynotes and talks throughout this week, you will have seen that the Nitro system is everywhere at AWS. The Nitro system is actually where our relationship with Annapurna, the division within AWS that's responsible for the Graviton processors, for Trainium, for Inferentia, that's actually a relationship that began very early in our Nitro journey. We are very, very passionate and dedicated to the security, performance, and efficiency values that come from investing in our own hardware. And it allows us to achieve an incredibly strong security foundation for our customers to build their architectures on top of. The Nitro system powers every EC2 instance that's been released since the beginning of 2018. It follows a strong hardware-based root of trust with a secure boot process. It's been designed to allow us to update every critical component of the Nitro system with minimal or generally no impact on a customer's workload. This means that this infrastructure can be maintained, patched, secure, without ever needing to impact a customer. And lastly, it also allows us to provide transparent line rate encryption of storage, networking, and memory. In the generative AI space, an excellent example of this is the Elastic Fabric adapter. Right? This is a networking device that can be exposed by one of our Nitro cards to an EC2 instance that allows tremendously high throughput and low latency, while also providing line rate transparent encryption to all communication between servers in a cluster or node. This allows for use cases like training or other high-performance compute use cases to be able to exchange data at a very, very fast rate, while also maintaining the security and the confidentiality of that data while it moves in transit. And all of this is done transparently, so the customers don't have to add an additional layer of encryption on top to receive this protection. Perhaps one of the most important security attributes of the Nitro system is that by designing the system from the ground up, from the silicon and the software that powers the system, we were able to set out with a bold goal that we delivered upon, which is to build a virtualization system that runs at cloud scale, hyperscale, across the world, with zero mechanism or capability for any AWS operator to access the contents of a customer's EC2 instance. It is entirely isolated from all AWS operators or systems. There's no SSH or general purpose access of any kind. There's no shell. All Nitro operations that are performed by systems or, in rare cases, human operators are performed via secure, authenticated, least privileged, authorized, and audited administrative APIs. And none of those APIs, by design, can provide access to the contents of a customer's EC2 instance. The Nitro system powers all of these accelerated instance types that are so critical to our customers' generative AI applications. That includes, as I mentioned earlier, some of our accelerators that are designed by AWS itself, like Inferentia, Trainium, Trainium 2 now, as well as GPUs provided by other partners such as NVIDIA or Intel with its Gaudi accelerator. We've published a deep dive white paper explaining the security design of this system. It's been validated by a third-party group, the NCC group. And we've actually added to our service terms that are applicable to all of our customers a clear and unambiguous statement that there is no operator access in the Nitro system. So a couple of capabilities in the Nitro system that are useful, valuable to understand as base primitives that can be really important for a truly secure generative AI infrastructure application. That is Nitro TPM, which is a standard compliant TPM 2.0 device that is available to EC2 instances. This allows an EC2 instance to gather and attest its state, to store or generate cryptographic data, and to remotely prove its identity at a cryptographic level to a remote system. Nitro Enclaves, that I mentioned earlier, allows the establishment of an additional isolated compute environment within an EC2 instance boundary, and also provides attestation, which in this case has a first-class integration enabling it to communicate with KMS. That's our key management system. So for example, in this case with Nitro TPM, you can have an instance. You can measure the contents, the code, the state of that instance, and provide an attestation to a remote system that can then be validated to prove that this instance is running the specific code in the specific configuration that you desire. We'll talk a little about what you might use Nitro Enclaves for, why does it exist, and how does it kind of relate to generative AI. So with Nitro Enclaves, right, as I mentioned, you have sort of a very strong outer boundary of an EC2 instance. There's no AWS operator that can ever get any access to that. But within the EC2 instance, if you've got very highly sensitive data, you want to think about the other things that are in that EC2 instance or could be in that EC2 instance that might be able to access that data. So you might have interactive users, you might have third-party libraries, applications, a rich operating stack. And what Nitro Enclaves allows you to do is to separate these two kind of domains out. You might have a larger domain of general purpose software, and then a narrower space of the specific code that needs to process and have access to your most sensitive data. Nitro Enclaves provide this additional isolation and security by default, right? They provide no storage. By default, they provide no remote access capability, and they provide no direct IP-based networking connectivity. Their only really communication path with the outside world is a secure local channel back to the EC2 instance that created them. You can think of this as basically a virtual serial cable. They're flexible, processor agnostic, can be large or small, and they have this capability of cryptographic attestation, as I mentioned earlier. This means that an enclave can prove to a third-party service or to AWS KMS directly proof of kind of who it is or what it is. It is a specific enclave file. It is attached to a particular parent instance that has a particular IAM role attached to it, as well as user-settable data like nonces, et cetera. This is a low-level primitive that allows customers to build things in really interesting ways. For example, right, the first-class integration with KMS enables you to effectively make it such that a decryption of a particularly sensitive piece of data can only be performed at the request of a specific, highly trusted and highly constrained enclave application. So let's change for just a moment here. I want to talk a little bit about sort of what confidential, a truly, deeply, exclusively confidential inference can look like at an infrastructure level, right? So customers are able to build a trusted, hardened, constrained environment where they load in what I'll term a hermetic compute environment, like a sealed environment where there's no remote access, and the data processing that occurs has been reviewed, audited, and is trustworthy. These instances have access to ML accelerators as well as Nitro TPM, allowing them to prove that they are, in fact, the hardened, confidential, and constrained environment that they were designed to be. This allows you to make certain assumptions about what this code will do and what guarantees can come along with providing information in there to, for example, be inferenced upon. When it comes to something like Nitro enclaves, right, you can do something similar here, right? So you can, for example, load highly confidential ML models into a Nitro enclave in an encrypted fashion, use the end-to-end encryption features of KMS to decrypt that model, and then inference on it using the CPU and memory resources available to the Nitro enclave. You can also do other things that aren't necessarily about inferencing or training an ML model using this capability that are really important for generative AI. You could pre-process or post-process prompts or completions. You might also use these, and this is actually something that was mentioned by our CISO, Chris, in his talk earlier this week. You might even use these for use cases like ML model testing, where you're able to actually maintain the confidentiality of the prompts themselves used to test a model by initiating your inferencing using an encrypted channel that starts within a Nitro enclave. And something that we've announced is coming soon down the road is our extension of that Nitro system end-to-end protection to ML accelerators, enabling customers to encrypt sensitive AI data using keys that they own and control, store the location, that data in a location of their choice, and then securely transfer that encrypted data into an isolated, confidential computing environment that they can trust for inferencing on their most sensitive data. This is something that we've planned support for in the upcoming NVIDIA GP200 NVL72-based platform, as well as Trainium 2. So these are all some of the basic capabilities that AWS brings to you, and some of the advanced functions and features that AWS enables for customers to build their own applications. But our stack, as we mentioned earlier, is a rich offering that gives customers choice for different types of applications and features and services that meet their needs. So I'm going to have Jason come back up to talk a bit more about the next layer in the stack, which is the generative AI tooling layer. If it's all right, I think, would it be OK? We'll handle questions after? OK.
Awesome. All right. Thank you very much, JD. As JD mentioned, we're going to move up the stack one layer, and we'll look at what we call the tooling layer, services for builders. And at this layer, there's one big service that we're all familiar with, and I'm sure we've all learned something about here at reInvent this year, which is Amazon Bedrock. Amazon Bedrock is our premier service for providing access to foundation models at scale without having to manage your own infrastructure. So this accelerates your ability to develop generative AI applications without creating or maintaining infrastructure. You just use a simple API, and you can choose foundation models from a variety of sources, both first and third party, and it's built with data security, privacy, and safety in mind. And we're going to go deeper onto each one of these topics. So the first thing that I mentioned is that we have model choice. And this week, we announced several new models under the Amazon Nova brand. So we have multimodal models that do video, that do text, et cetera, as well as models from Anthropic, Meta, et cetera. So customers have told us one of the most important features is this model choice, and it allows you to experiment and decide which model fits your particular use case the best. And this has security implications too, and safety implications as well. So let's take a look at some of Bedrock's data security and privacy features. And you'll note the first bullet on this slide: none of your customer data, none of your data is ever used to train the underlying foundation models. And furthermore, your customer data is never shared with any third parties or with AWS itself. It's very, very important to us that we keep that data privacy that we do for all of our other services also apply to Bedrock as well. If you look at data in transit and at rest, we encrypt that data using KMS for encryption at rest, and in transit with TLS 1.2 as a minimum as well. And when we talk about network transits, we'll take a look at private link and using VPC endpoints in order to connect to Bedrock with a private endpoint not using the public API. So let's take a look at how we actually implement some of these features. It's one thing to say all of that, but what I want to do is show you how this is actually architected behind the scenes. And what we want to do is show you how Amazon is working on your behalf on our side of the shared responsibility model to keep your data safe. So if we look at data flows into and out of Amazon Bedrock, here's just a conceptual diagram of what a network would look like, both from a corporate network, right, on-premise network at the bottom, as well as you may have some resources inside of your Amazon VPC on the left-hand side that want to talk to the Bedrock service. Of course, the Bedrock service API endpoint is shown in the center, and most customers will use the public API endpoint, and they can access that either directly from the internet, from their on-premises network, or they can use a NAT gateway inside their VPC in order to reach that endpoint. You can, as I mentioned earlier, choose to use a VPC endpoint. And this allows you to do private point-to-point communication between your VPC and our services that support private link. So you can see here, you can even extend that capability to your corporate network through the use of services like AWS Direct Connect. But that's just demonstrating how we can secure the communication between you and the endpoint. What happens behind the scenes? Well, behind the scenes, of course, there's an orchestration layer. As I mentioned, we have a variety of model choices. So part of this is deciding which compute stack to send your request to, and that depends on which model you choose. And you'll note there's a one-way arrow. The one-way arrow from the base model S3 bucket that loads that model into the compute instances for that particular model choice. As I mentioned earlier, there is no use of your customer data to train a model. First party, third party, it doesn't matter. We never use customer data to train our models for Bedrock. And then I mentioned that we also use third-party models. You can choose to use Meta's models, Llama. You can choose to use Anthropic's Claude model. The way that we do that, and we're using our own best practices for least privilege and separation of concerns, such that we give those model providers their own dedicated AWS accounts where they upload their model artifacts into S3. When we decide that those are ready to promote into production and be exposed to customers, that data is copied into the model deployment account, and then you're able to access it. Again, going back to the point, the central point, that none of your customer data is ever used to train or change these models in any way. Inference is a function. You go data in, data out, and that doesn't change the model during that time. And of course, along all of this, wrapped around all of these capabilities, is our foundational AWS security services. So things such as CloudTrail to audit the API calls that occur. CloudWatch can be used if you choose to log your prompts and completions. You may choose to do that. It is optional, and it's something that you have to opt in, and you can encrypt that data with your own KMS key. So customers can be assured that if they do choose to log their own prompts and completions, that data is kept safe within their own account using their own keys. And then finally, we have tools such as IAM access control for controlling access to models, as well as guard duty, taking a look and finding anomalous activity, even in generative AI services, the patterns at which those APIs are accessed. So all of those foundational security services still apply here and are integrated into all parts of our Bedrock service flows here. Now, I mentioned governance and auditability earlier, right? So monitoring and logging capabilities. As I mentioned, you can monitor your API activity through CloudTrail. You can also track usage metrics using CloudWatch. And we help you support compliance standards, right? So these are things that we can help you do, like from the capabilities that are present in our products. If you need to meet any of these compliance standards, we can help you do that, right? We have foundational capabilities here, and of course, it's a double-sided part of the shared responsibility model, but we can help you out with that. Now, there's one thing that I want to say about generative AI security. And a lot of our talks and a lot of information has been shared about how we secure the foundation models, we help with encryption, network controls, et cetera. But I think a very important piece to keep in mind here is that this is simply the tip of an iceberg. The bottom layer of that iceberg is your data. I like to say that generative AI is really not much use without access to your own sensitive company data. And so when we think about that, one thing to keep in mind is how you manage access into your data in a way that you keep it private and secure. So there are three main patterns that we see customers using in order to gain access to their sensitive data into a generative AI-based system. The first one is retrieval augmented generation. So this is a way that you can search existing knowledge corpuses for relevant information to a certain query, and then those relevant informations will be augmented in, hence the name, into the prompt, into the generative AI model, and then it can use both the user's prompt as well as the relevant information gleaned from inside data sources to come up with an answer. And this requires no change to the foundation model. You can use a standard foundation model to perform this. Same thing with AI agents. And here, instead of doing a search on a vector database, an AI agent may make an external API call to request data. Some people also allow you to take actions through AI agents. So you could, for example, have an LLM decide that as a result of a user's query, it should call an API on the user's behalf to take an action. And then finally, we have model customization. This is where you take an existing foundation model and you augment the model itself with new data, generating an entirely new model artifact with different model weights. You can create a private copy of the foundation model at that point, and again, we provide you security around that with the ability to encrypt that final model, as well as control access to it when you want to run inference on it. So what are some ways that you can address the security concerns when you are integrating your generative AI application into your existing enterprise data sets? I like to really talk about how do we implement traditional security controls into that framework. The first thing that I like to say is adopt a policy of zero trust. If you are doing ubiquitous authorization throughout the entire life cycle of your generative AI application, from when the user inputs a query into the system all the way to the response that comes out, that means you have identity tracked throughout the entire process, and you are performing deterministic, auditable security controls, authorization controls, at every stage of that pipeline. So that means you start with identity. Apply a policy of least privilege, use AWS Identity Center, and then you can add fine-grained access controls. You can use existing services that we provide, such as AWS Verified Access, if you wish, and Amazon Verified Permissions. And then, of course, to provide access to the system as a whole, you can use a zero trust capability such as verified access, so you don't need a VPN or something else to access the system. Well, how do you implement this? Where do you put these access controls? Well, let's take a look at an example. So this is a very simplified diagram of what a generative AI application may look like. You have your users on the left-hand side. The final response that's generated by the LLM is on the right-hand side. And of course, we have our sensitive data sets and APIs along the bottom. So when we start, we have our users log in to the generative AI-driven application. Of course, we use Identity Center to identify that user, authenticate that user, and authorize their access into the application as a whole. But that's not enough. The next step that we need to take is whenever that data enters into this agent, this orchestration engine. This isn't the LLM at this point. You can use either something like bedrock knowledge bases, bedrock agents, or you can build your own. That agent is going to use that identity information and make authorization decisions when attempting to access data or make API calls. That means that by the time the data exits the agent and enters the foundation model, only the data and the actions that the end user is able to access or perform will be fed into the foundation model, because it is too late to perform authorization once you have entered the LLM. I think the most important thing to keep in mind here is you want to reduce the agency of that foundation model, that LLM, to make any security decisions about your data, about your access to data, or your access to APIs. You want to focus on how can I put those decisions in the hands of deterministic traditional security controls that I can audit, that I can understand, and it's going to make my risk calculus much, much easier. Now, of course, as security practitioners, everything should be a layered approach. And so this talk would not be complete without a discussion of bedrock guardrails. And what I like to think about when I think about bedrock guardrails is it's helpful for safety, for AI safety. So if I have concerns that, let's say, the LLM will generate harmful content, or that a user might attempt to ask the LLM a question that's inappropriate, bedrock guardrails is my go-to service. So bedrock guardrails can evaluate prompts and model responses no matter what the foundation model. You can even use bedrock guardrails without foundation models at all. You can call it via an API and have it evaluate an input or an output against your rules and guardrails. And you can configure thresholds for filtering harmful content, jailbreaks, prompt injection attacks. Define, disallow, denied topics, remove or mask personally identifiable information. And a new feature that's come out recently is the ability to filter hallucinations by detecting groundedness and whether the responses are relevant to the user's input query. And this happens both on the user input and the foundation model output. So you can see the 6 different capabilities provided by bedrock guardrails right there in the center. And this can, as I mentioned, happen both on demand. You can ask for a bedrock guardrail evaluation of an input or an output, or it can be performed in line for a call for inference into bedrock. And we'll move up the stack. The last layer, the top layer, are enterprise-ready solutions. So we just finished talking about how we can build secure generative AI applications inside of AWS. What if we want to take our existing corpus of data and expose it to an already built generative AI application and do it securely? Well, one way you can do it is through Amazon Q Business. Amazon Q Business is our pre-built system that delivers quick, accurate, and relevant answers to your business questions securely and privately. You can point Q Business to your existing data silos, and it will be able to answer your users' questions based on the data that is provided to it. And it connects to over 40 popular enterprise applications and document repositories. Of course, this talk wouldn't be remiss without a discussion of its security and safety mechanisms. So you can give it guardrails, just like I mentioned before, in order to understand and filter out any toxic responses or requests. You can restrict your responses to enterprise content only. This is going to give you an ability to address issues with relevance and with hallucinations. And you can use, of course, AWS Private Link, like we mentioned with Bedrock before. That way you can access Q Business securely through a VPC endpoint from your VPC. And I think most importantly here is that it integrates with AWS Identity Center. And as I mentioned, I think one of the key pieces with the secure use of any generative AI application is that you're putting identity at the center of that application. And Q Business absolutely does that. Again, from a data privacy and governance perspective, Q Business, you are always in control of your data. Customer data, again, is never used for training, fine-tuning, improving machine learning models by AWS ever using Q Business. Again, customer data is encrypted in transit, and at rest, you can use AWS Key Management Service keys, customer managed keys, in order to make sure your data is kept private and secure. Now, one of the things that is always a concern when looking at generative AI applications is the relevance of responses and understanding that the responses given by the application are accurate. And so Q Business has a great feature. You might not be able to see it all the way in the back, but if you read that text on the right-hand side, the response to the user's query, you'll notice that there's a little box that says sources at the bottom. And that's because whenever Q Business provides an answer to a user query, it gives both those superscripts at the top inside the response itself, as well as that box that says sources there. You expand that out, and it will give you links to all of the original sources that powered this answer. That allows the user not just to read the data that was generated for him or her, but they can also go back to the original source and validate that, yes, that is what that source said. It saves them a ton of time, and it gives them much, much more confidence in that answer that they were given. The last thing that I think Q Business does great from a security perspective is custom plugins. Let's say that you have an enterprise data source that isn't covered by one of our 40 pre-built plugins. Or you'd like users to be able to not just ask questions of data, but also to take actions via APIs. This is where Q Business custom plugins can come in and help. So with Q Business custom plugins, you can take OIDC authentication and connect to any OpenAPI specification API. You give it the OpenAPI spec, and then it will do OIDC authentication for that user. And now that user is able to call external APIs, take actions, query data, all within the Q Business application interface, and using their correct identity so that we're always making sure that the user only gets access to the data and actions that they are authorized to take. The nice thing about Q Business is that it integrates all of that together for you, so you don't have to actually program anything. And with that, I'm going to hand it back to JD just so we can put all of this together. JD.
Thanks a bunch, Jason. So, as we come towards the end of our session today, I want to leave folks with just a few quick thoughts. And the first is, I think, what the most powerful attribute to a reliably secure system is, and that is defense in depth, right? Obviously, generative AI applications are disruptive forces. They're new technologies that are available, and they really come and they shine through access to our sensitive information. And in securing these systems, it's absolutely, I think, paramount for us to make sure that we're thinking about layered, rigorous approaches that cover all sorts of elements and attributes of application security. We want to cover data protection, application protection, infrastructure protection, threat detection and incident response, identity and access management, network and edge protection, policies, procedures, and awareness. Right? We need to frankly follow the best practices we've established as an industry over years and years and years, and adapt them to the new challenges and technologies that generative AI brings to bear. And on that note, it's important, I think, for us to remember that AWS features, services, they don't begin with generative AI technologies, right? AWS offers a rich suite of security, identity, compliance services, foundational infrastructure and operational observability logging services, in addition to generative AI services. And that no matter which level of the AI stack you're operating, whether that's building your own generative AI applications on top of AWS infrastructure primitives, leveraging the power of Bedrock or SageMaker tooling, or even operating at the higher AWS generative AI application service level like a Q-Business. That all of these services benefit from their availability to operate within the broader AWS ecosystem, and to be able to benefit from things like automation as code, ubiquitous logging and monitoring, and other security, fundamental security technologies at AWS. So we want to leave you today with a few quick resources on our secure generative AI approach, a blog that we put out earlier this year discussing some of the specifics of our secure approach to generative AI infrastructure, as well as a blog post covering some of the specific topics of data authorization in generative AI applications that Jason spoke about earlier. So thank you very much. We appreciate so much that you came to speak with us today. We know there's a lot of great content, and we're frankly flattered that you came and chose to spend some of your precious time here with us. Please don't forget to fill out the survey. And of course, we'll both hang around afterwards, and we would love to chat, discuss, and answer any questions anyone has. Thank you.